Anyone? No one? Amal? All forgot. Akash? Kiran? Okay. So yesterday we have, am I audible, right?
Yes, sir.
Okay, okay. So yesterday we started about the flat rolling and its analysis. So in that case only we have taken the schematic diagram of the flat rolling process. Then we derived some equation. For example, draft we have talked about the initial thickness minus the final thickness. Then we talked about the reduction. And then also when we assume that, or when we thought that the initial volume, whatever we are initial volume of the material also it will be equal to the final volume of the material, right? So that instead of this length also we have changed to the velocity of the initial raw material, then also the final velocity also we have replaced. Then finally also we have talked about the forward slip. So that also we have derived the velocity of the final product minus the speed of the roller and divided by the speed of the roller. That also we have talked. Then the epsilon and the average flow stress, these are and the maximum draft also we have derived mu square r, where mu is known as the coefficient of friction and r is the radius of the roll. Okay. Then what we have talked about, finally we have talked about the what is this L. Okay, L also we discussed the contact length. Okay, equal to R into T0 minus TF to the power 0.5 or half. Okay, and then also the force applied, that also we have discussed flow stress into the width into the length of contact. Okay. So the pressure also what we discussed 2 pi NFL. That these are also we have discussed. So based on this, today we will do 2 3 numerical. So the first numerical, the question can you see a 300 wide strip with a thickness of 25 is fed through a rolling mill with two powered roll, each of radius 250 the work thickness is to be reduced to 22 Okay, so you have to, because many students they are if you will not write the given, then you will find the some difficulty in the in between when you are giving doing the solution. So you have to write what are the parameters are given, then what to find out, because some students, for example, in the last exam also I asked the flow stress. Okay, but in the exam actually we have not done that one. But if I add there, then students only they are looking the PPT. Okay, so they missed. So they told, sir, I didn't read that one. Okay, so if you write what are the given document or given information you have, then what to find out, then you have to find the solution. The work thickness is to be reduced to 22 in one pass at a roll, speed of 50 revolution per minute. The work material has a flow curve defined by K equal to 275 megapascal and N equal to 0.15. And the coefficient of friction between the rolls and the work is assumed to be 0.12. Determine if the friction is sufficient to permit the rolling operation to be accomplished. If it is, calculate the roll force, torque, and power. Okay, so that means you have to find out F, you have to find out T, and you have to find out P. Okay, so all the equations are there. And what are the given value, you have to write. Then you can do it. So please do. At least you can write what are the given value. Have you wrote all the formulas?
Yes, sir. Right.
Yeah, okay. Otherwise, I will go back if you want to see. So first you have to write what are the given information you have. All the students please do, because a little, the question looks very long. But if you write all the terms, then I think it will be easy because all the formula you have. So what is T0?
Sir, 25.
Yeah, T0 is 25 and TF is 22, right?
Yes, sir.
Okay, so you have to find out the draft. D
So
equal to
3
T,
mm.
yeah, D equal to 3 mm, fine. Then what you want to find out? You want to find out the maximum draft, because if you have draft, then maximum draft how much? Equal to mu square R. Okay, mu is given 0.12, right? R is given 250.
3.6.
Yeah, 3.6 mm is a maximum draft. Yeah. All the units you have to write,
Yes, sir.
mm.
Yes, sir.
Yeah. Then what you need, if you want to find out F, T, and P, you need L, right? Contact length. So can you find out contact length? L equal to R into T0 minus TF whole root over.
Sir, somewhere near 28 it's coming, sir.
Yeah, 27.4.
Okay, okay, sir.
Yeah, 28. Okay, it's fine. Not an issue.
28, 27.38 I'm getting.
Yeah, fine. Okay, so now you got D, you got D max, you got L. Okay, so can you find out force now? No, force you cannot find because you need average flow stress. So YF bar can you find? K epsilon to the power n divided by 1 plus n. So epsilon we do not have. So you have to find out epsilon first. Epsilon equal to ln T0 T0 by TF.
It's coming 1.02, 0.1278.
Yeah, fine. Okay,
Yes,
so
sir.
if
0.12.
yeah 0.128. Okay, yeah.
Yes, sir.
So yeah, now YF bar average flow stress. So all the units please write. Okay. Other student please do, because only 3-4 students they are responding.
Sir, is it 175.67 megapascal?
Megapascal, yeah, fine. Okay, so now you got D, you got D max, you got L, you got epsilon, you got YF bar. So now the all three term you have to find out F, T, and P. So F equal to YF bar WL. Okay, so YF bar you have, L you already got, W also given 300 mm.
Somewhere close to 14 lakh 44,000.
Yeah, but what is the unit?
Newton, sir. not
Yeah.
minute.
Because a megapascal into mm square. So Newton.
Yes, sir, Newtons.
Yeah. Others are you getting?
What is the answer?
I think the same. 1144786.
So I'm getting a bit different, sir.
Yeah, it's okay. It's okay. Because if answer is wrong, you do not need to worry. All these steps should, but it should not be very big vary. For example, let's say the answer will be 0.5, but we are getting 500. Okay, but if it is close, then not an issue. All these steps should perfect. Because when we are doing calculation, sometimes we are making mistake. Yeah, so if F you got, then what about T? So you have now F, you have L. So T equal to 0.5 FL. But F, how much you are getting, Aditya?
Sir, I am getting 1444007.4.
But it's okay, because almost close.
Okay, sir.
Because this is a 7-digit number, so almost close.
Yes, sir. 14 lakh 44,000.
Yeah, it's okay, no problem. Yeah, Amal, why you are silent today?
Yes, sir. I just had a wrong in one of the formulas.
Okay, so F, which one? F?
Yes, sir.
Okay, F equal to YF bar WL.
Okay,
If you
sir.
want, you can download the PPT already I have uploaded. Okay,
Yes,
but
sir. I just downloaded, sir.
yeah, but do not see the solution.
Okay, sir.
Then T have you got 0.5 F into L. Sai, what about you? Kiran Dev, Anirudh. Kunal, Dia,
Sir, for T, we have to convert it, no?
T.
We have to convert it from mm to.
Yeah, mm to meter you have to convert because it will be in torque will be in Newton meter. So you have to convert to mm to meter.
I am getting, sir, 19782.
Yeah, fine. Newton meter, okay. Then
Yes,
what
sir.
is the P? Power. This equation is written there on the upper side, 2 pi NFL. Okay, N is given 50 revolution per minute. Okay, so you can see here. So initially we have done the draft. Okay, so T0 minus TF, then we converted the Dmax, and then the length of contact, and then the epsilon. Step by step, if you go, you will not find any difficulty. And also some students, what I checked from CAT1 also, when you are writing, you are sometimes you are doing like a rough work. Like in the side, you are writing A equal to this one, B equal to this one. You have to do because this is required for this solution. For example, if I need Dmax, I cannot write in the right side of D. Okay, because if you are writing in the right side somewhere, you are making a line and you are writing. So this is you are thinking this is secondary. Okay, so everything is important for this solution. Right. So after epsilon, then you have to find out the average flow stress. Then in the right hand side, if you want to find out the force, then the torque, then the power. Okay, so power will be around 12,432,086 Newton meter per minute. Or if you want to convert to watt, you can make it 207,201 watt. Okay, and
Yes,
if you
sir,
want,
1, 2, 4, 3, 6,
yeah,
6.
little different.
No, sir, like it's
Okay.
12, 4, 2, 2, 3, 6, 6, 2.
Okay, fine. And if you want to convert to horsepower, you can take. If you do not want, this is also no problem, not necessary. Okay, the last part. If you want to convert to horsepower, this is also okay. If you do not want, that is also fine, not an issue. That is not any stick to make it to convert to horsepower. But normally we are converting the power. But if it is if you are forgetting also, you do not need to worry. Okay. Everybody done? First one.
So done.
Yes, sir.
Okay. So we will go for the second one. Yeah. A 30 mm thick plate made of low carbon steel is to be reduced to 25 mm in one pass in a rolling operation. As the thickness is reduced, the plate widens by 4%. Yield strength of steel equal to 174 megapascal and tensile strength equal to 290 megapascal. The entrance speed of the plate is 77 meter per minute, roll radius 300 mm, and a rotational speed 45 revolution per minute. Determine the minimum required coefficient of friction that would make this rolling operation possible. The second part is exit velocity of the plate, and the third part is forward slip. Okay, so that means you have to find out mu in the first part. Exit velocity of the plate means Vf. Okay, and third part is forward slip means S. So at least you have to write all the given, whatever the given you have, and then you can write out the find, what to find, and then go for the solution. Mugilan, are you doing? Pranav?
Yes, sir.
Yeah.
Solving.
Yeah. Prayag. Nihar. Vishnu.
Yes, sir. Solving, sir.
Right. So you have to find out the draft first. Okay. So you have a T0.
Yes,
You
sir.
have T.
So,
You have TF.
Maximum draft is 5 mm.
Yeah. Draft is 5 mm. And then what should be the mu?
0.13.
0.13. Yeah. Yeah. Fine. Okay. So first part is finished. Then second is exit velocity. Okay, so for exit velocity, this is for W part, it is given. As the thickness is reduced, the plate widens by 4%. So that means WF equal to 1.04 W0, 4%. So which equation you will put?
So that initial T naught W naught, that one.
That you will put because if you have T0, you have T0, right? You have TF, and then
Yes.
you and V0 you have, right?
Yes, sir.
V0 you have. So
Yes.
WF equal to 1.04 W0. So you can put that
Yes.
equation.
So we have W naught in terms of W. So, okay.
Yeah, yeah. So you will find VF.
Yes, sir.
How much?
It's coming 88.83
Yeah, so unit.
minutes per minute.
Minutes
Sorry,
or meter per minute?
Sorry, meter per minute.
Yeah, meter per minute. Okay, so VF is clear. So now the last part you have the forward slip. Forward slip is S. S equal to VF minus VR divided by VR. The whole divided by VR. Okay, so you have VF now, you got, but VR you have to find out the roll speed. So what is the formula of VR?
2 pi Rn.
Yeah, okay.
So final S I'm getting 0.04.
7.5. Yeah,
7.
yeah, fine. Yeah, okay. Okay, this is small one. You can see the question is almost like 5 lines. So you can see how we are doing very smoothly. For example, again, I'm repeating, if you write the given, then it will be much more easier for you. Okay, so you have to find out the maximum draft equal to mu square R. Okay, so before that, if you want to find how much is Dmax, and this is T0 minus TF equal to 5 mm. So mu square now you can find out mu square will be 0.0167. So mu equal to 0.129, right? So now the second part is given the thickness is reduced and the plate widens by 4%. Okay, so if the plate, that means the WF, if it is increased by 4% or widened by 4%, so that means the WF equal to 1.04 W0. Okay, so this equation already we know T0 W0 V0 equal to TF WF VF. So instead of this, this value you have to put because T0 is given, then TF is also given. So instead of you have to find out VF, na? So instead of this V0, okay, V0 is also given. Okay, so we will find out VF equal to 88.85 meter per minute. Okay, because the W0 will be cancelled. If it will be cancelled, so we will find out VF. Right? Second part is clear?
Yes, sir.
Yeah, okay. And the third part now, you have to find out the forward slip. So forward slip is VF minus VR by VR. So before that, you have to find out what is the value of VR. Okay, so VR equal to the equation we have R into omega. Omega is the angular velocity. Okay, omega is the angular velocity. So angular velocity already we have derived in the previous class. So the VR will be 2 pi Rn. Okay, so you will get the VR 84.82 meter per minute. So if you have here, now you can put the value here. So you will get S equal to 0.0475 or 048. Okay. Is it clear?
Yes, sir.
Yeah. Other student, have you done? If any difficulty, you can just ask me. We will do one more numerical.
Doing, sir. Doing, sir.
Yeah, yeah. Amal, any doubt?
No, sir.
Anirudh, any question up to now? Ayush? Because you have to respond. If you will not respond, then how I will know? Of course, from next week, like you cannot be silent. Yeah.
Yes, sir.
Welcome, sir.
Johan? So you can be hide for this week only. Whatever you can do, you can do this week only. Benald?
Yes, sir.
Yeah. Doing? Yeah. Okay, we'll go for the next one. So you can read. Yeah. So a hot rolling mill has rolls of diameter 24 inch. Okay. It can exert a maximum force 400,000 pound. Okay. The mill has a maximum horsepower of 100 HP. Okay, so that's why I put here a little bit of HP because we have to convert. Okay, and it is desired to reduce a 1.5 inch thick plate by the maximum possible draft in one pass. The starting plate is 10 inch wide. In the heated condition, the work material has a strength coefficient of 20,000 pound per inch square and strain hardening exponent is 0. Determine the maximum possible draft. Then second is associated true strain and third one is maximum speed of the rolls for the operation. So that means you have to find out D max, then true strain is epsilon, and then the maximum speed. Okay.
Okay, sir.
Maximum speed of the roll. So that means you have to find out VR. Okay. Somebody calculated D?
0.3.
Yes, sir.
0.3 inch. Yeah,
Ah, yes.
yeah, okay. First you do by yourself. If you are not understanding, then go for the solution. You can see, but before initially do not see the answer. Because now you will have the physical exam, right?
Yes, sir.
So you have to practice by yourself.
Yes, sir.
So you can see the first part I have shown here. So the draft you have, because this is written that it is desired to reduce a 1.5 inch thick plate. Okay, so that means the initial thickness is 1.5. So D equal to 1.5 minus TF. Okay. And the average flow stress you can take as K is given. How much is K? The strength coefficient is 20,000. Okay, 20,000 epsilon to the power 0 divided by 1 plus n. Okay, so n is 0. So this is 1. Okay, so epsilon value is not given, but epsilon to the power 0 will be 1. Okay, because any value if you put instead of epsilon, because the power is 0, so you will get 1. So this YF bar equal to 20,000, the same value, 20,000 LB per inch square. But in exam, some students what they're doing, if this is coming equal also, they're writing directly YF bar equal to, let's say, K. They're writing. Okay, but you have to put the value, then only you will get YF bar equal to K. Directly you cannot put. Okay. Then you can find out the force. And also before that, the contact length also you have to find out. Okay, R into T0 minus TF, or T0 minus TF instead, you can also take a D to the power 0.5 or whole root over. Okay, and this value you cannot find because D max is not there. You have to find out. So you can just put instead in the formula of F. So you will get D equal to 0.333 inch. The first part is clear?
Yes, sir.
Yeah. Other student, Amal?
Yes, sir. Yes, sir.
Yeah, Vishnu.
Yes,
Kiran?
sir.
Yeah, Kiran? Aditya?
Yes, sir.
Yeah, only 4-5 students. Others what happened? Ayush, if you will not respond, then I will just call. Dia, Else, Pranav Dilep, Pranav S.
Yes, sir. I understood.
Yeah, and the second part, it is asking the associated true strain. Okay, so that means you have to find out the epsilon. So epsilon equal to ln T0 by TF. Okay, so if you have D value and T0 is given, so can you find out TF now? How much is TF? You can see the second part. Okay, so you need epsilon. So epsilon equal to ln T0 by Tf. So you need the value of T0, sorry, Tf. So T0 is already given 1.5 and D already you have got 0.333. Okay, so you will get Tf equal to 1.167. Okay, so now you can put epsilon equal to ln T0 by Tf. So instead of Tf, you can put here 1.167. So you will get 0.251. Fine. Second part.
Yes, sir.
Okay. And the third part now only you have to make a conversion. Okay. So the maximum speed of the rolls for the operation. But it is asking here, the mill has a maximum horsepower of 100 HP. Okay. Because you cannot take HP directly here. So I put here, here you have to make a conversion because which value you have to take. Okay. So here actually we have to take this value because we need inch because everything is our inch pound per a minute. So 1 HP equal to 396,000 inch pound per minute. This value you have to take. Okay, because this is everything in inch and pound. So if 100 HP, so it will convert to 39,600 then 000 inch LB per minute. Okay. Then contact length you can find out. Then P. Sorry, not P. You will find out how much N. N is given. No, N you have to find out. Okay. So contact length will be 2 inch, right?
Yes, sir.
Yeah. And the P will be this value. Okay. And this value equal to this value because maximum possible horsepower we are giving. Okay. So this one equal to this one. So from here you will find out N. Okay. Because N value is remain. So you have to find out the N. So N you will get 7.88 revolution per minute. So if you have N now, then you have to find out VR, the speed of the roll 2 pi Rn. Okay, because R is there, N you have already got, so you will find 49.5 feet per minute.
Okay, sir.
Okay. You can check just this in unit because I think it will be feet per minute or inch per minute. Or maybe after inch it is already converted. Just you can check this one. Okay, maybe I will cross check again. Yeah.
Sir, what's
Yeah.
sir?
The last part I'm asking the VR equal to 49.5 feet per minute or inch per minute, or after inch it is already converted to feet per minute. Just you can cross check this one. I will check again.
Okay, sir.
Okay, this last part because because I did actually yesterday, but I could not find where I did. Okay, so I will again cross check.
Okay,
Maybe
sir.
I forgot. Maybe it was inch per minute, or maybe after inch it is already converted to feet per minute. Just I will cross check. Okay, if it is maybe I will cross check because I have taken the value of the feet one 33,000 or 396,000
I
this
think
value.
it's 15 inch. Sir.
Feet per minute, na?
Yes, sir.
Okay, okay, okay. No, why I'm asking because initially we have taken inch, so that's why why directly put here feet. So from inch I think it is converted to feet probably. Okay, okay. Oh, I think yes. This one, this is converted 12 by 12, na? Yes. So this is converted already. So that means this is feet per minute. Yeah. 12 by 12, na? Because this is R. R is 12. Okay, because R is 12 inch. So divided by 12 means it's converted to feet. Okay, so if you want to make it in inch also, this is fine. So you do not divide by 12. Directly you can make 2 pi into 12 into 7.88. Okay.
Yes, sir.
Fine, sir.
Okay, fine. So any question up to now? So all